Dear friends, today we discuss how to find solution of first order and first degree differential equation. Actually, friends, it is very difficult. It is difficult to solve a first order and first degree differential equation because there are so many methods. We can't apply only one method to solve this equation. Today we discuss a method, first method, that is known as variable separable method to solve a first order and first degree differential equation. Dear friends, if a differential equation expressed in the form derivative of y with respect to x is equal to function of x into function of y, then we can solve it in variable separable method. Here there are two variables, one is x, another one is y. Function of x and function of y is in multiplication position, they are multiplied. So we can easily separate function of x dx and function of y dy. Then we can able to integrate it and find its solution. That means now we separate function of x dx and function of y dy. Implies dy by function of y is equal to function of x dx. Now see friends, function of x dx and function of y dy, variable, separable, already done. Now we can integrate to get its solution. Now integrating both the sides, we get the solution, and there is one arbitrary constant in this solution. Also, in a particular case, we can also apply variable separable method to solve a first order first degree differential equation. If a equation is in the form derivative of y with respect to x is equal to function of x plus y, then by substituting x plus y, a new variable, then we can able to solve it in variable separable method. Derivative of y with respect to x must be in function of x plus y form. For example, by substituting x plus y is equal to t or any variable z, I put x plus y is equal to t. What is the value of derivative of y with respect to x? Taking both sides derivative with respect to x, 1 plus derivative of y with respect to x is equal to derivative of t with respect to x. Now, what is the value of derivative of y with respect to x? We remove the variable y. It is derivative of t with respect to x minus 1 is equal to function of t. We put x plus y is equal to t, ft. Implies derivative of t with respect to x is equal to ft plus 1. Function of t plus 1. That means the right side of this equation is also function of t. I take it as gt, that is function of t. Now we can separate the variable t and x. Derivative of t dt by gt is equal to dx, and function of t dt and function of x, there is no function of x here, only dx. Now we can able to integrate both the sides to find the required solution. Integrating both the sides, we get the required solution and this one. Since we take integration one time, so the solution has one arbitrary constant. Again I repeat friends, if a function, if in first order first degree differential equation, if derivative of y with respect to x is in form of function of x into function of y, then we can solve it by variable separable method by this way. If derivative of y with respect to x is form of function of x plus y, by substituting x plus y with another variable, we can also able to get solution by variable separable method. I done it here. I give two examples. Let us consider a differential equation. Let us consider a differential equation 1 plus x square 1 plus x square y dx plus 1 plus y square x dy is equal to 0. Now we find what is the value of dy by dx. If the value of dy by dx is product of function of x and function of y, then we can solve it by variable separable method. What is the value of derivative of y with respect to x? Is equal to 1 plus minus 1 plus x square y by x 1 plus y square minus dy by dx. This is right. Please see right hand side of this equation. This is 1 plus x square by x. This is function of x. And y by 1 plus y square. This is function of y. In right side of this differential equation, let's see. This is 1 plus x square by x. This is function of x. And y by 1 plus y square. This is function of y. That is right side is product of function of x and function of y. So we can solve it by variable separable method. Let's separate the variable x and y. Implies 1 plus y square by y by cross multiplication is equal to minus 1 plus x square by x dx. Now we integrate both the sides. Implies integration of 1 by y plus y square by y dy is equal to minus integration of 1 by x plus x square by x, that is x dx. Implies 1 by y dy, integration of 1 by y dy, that is log y dy, integration of y dy, y square by 2 is equal to minus dx by x, integration of derivative of x by x, that is log x, plus integration of x with respect to x, x square by 2 plus c. This is the required solution of this differential equation, which we solve by applying variable separable method. Also I say, if a function is in function of x plus y form, by substituting x plus y with another variable, we can solve it by variable separable method. Let's see an example. Let us consider a new differential equation. Derivative of y with respect to x minus 1 is equal to e to the power x plus y. Implies derivative of y with respect to x is equal to e to the power x plus y plus 1. The right hand side is not product of function of x into function of y, but the right hand side is form of function of x plus y. E to the power x plus y. This is function of x plus y. 1. That means 1 is x plus y to the power 0, constant. This is function of any variable. 1, that is x plus y to the power 0. That means the right side of this equation is in function of x plus y form. Let's put x plus y with new variable. I take it as t, implies 1 plus derivative of y with respect to x is equal to derivative of t with respect to x. Implies what is the value of derivative of y with respect to x? Derivative of t with respect to x minus 1 is equal to e to the power t plus 1. Implies derivative of t with respect to x is equal to e to the power t minus 2 plus 2, e to the t plus 2. Now we make separate function of t and function of x for integration. Implies dt by e to the power t plus 2 is equal to dx. Function of t dt and function of x. There is no function of x, only dx. They are separated. Variable is separated. Now integrate both the sides. Now integrate both the sides. Implies e to the power t plus 2 implies e to the power minus t by e 1 plus 2 e to the power minus t dt is equal to x plus c. I take e to the power t as 1 by e to the power minus t for making integration by substitution. 1 by e to the power minus t cross multiplication. This value is e to the power minus t by 1 plus 2 e to the power minus t. Now implies derivative of 1 plus 2 e to the power minus t by 1 plus 2 e to the power minus t is equal to, let's see, what is the derivative of the denominator? Minus 2 e to the power minus t. Minus 2 e to the power minus t. But here is e to the power minus t, for which I divide it with minus 2. To keep the integration formula, derivative of x by x is equal to log x is equal to x plus c. Implies minus 1 by 2. This integration is in form of derivative of x by x. Derivative of denominator by denominator. That is, its value is log 1 plus 2 e to the power minus t is equal to x plus c is equal to x plus c. This is the required solution. Here already integration is over. Only we have to put the value of t, that is x plus y. We put here x plus y in place of t for getting the required solution. This is variable separable method. Now I ask a question. Please give its answer in comment box. What is the solution of the first order and first degree differential equation sin x into cos y dx plus tan x into sec y dy is equal to 0. Sin x into cos y dx plus tan x into sec y dy is equal to 0. Dear friends, please solve this and write the answer in comment box. Thank you.